Hello everyone, welcome back to my channel Learn with Mukul. So in this video I am going to teach you about the basic concept of CPU scheduling algorithms. So in this video I am going to teach you what are the algorithms which is used in CPU scheduling, which are basically FCFS, SJF and round robin algorithm. FCFS stands for first come first serve, SJF stands for shortest job first, and third one is round robin algorithm. So basically CPU scheduling algorithm means it is a process of determining which process will own CPU for execution while another process is on hold. Like suppose there are two processes. If process 1 requires 10 seconds and process 2 requires 5 seconds. If the CPU had decided to complete one particular process, suppose P1, so it will give 10 seconds to complete that particular P1 and keep that P2 on hold. This is how CPU scheduling algorithm works. So there are basically two types of CPU scheduling methods. First one is preemptive scheduling, second one is non-preemptive scheduling, and which is also called no interruption, and preemptive scheduling which is called interruption. Means in preemptive scheduling there is an interruption, there is a breakage while the process is being executed, and on second which is non-preemptive scheduling, which means there is no interruption while the process is being executed. Now there are some important CPU scheduling terminologies which you should know while dealing with the numericals of these three types of algorithms. So first one is burst time. So it is a time required by the process to complete execution. It is also called running time. So basically burst time means the total amount of time taken by the process to complete its execution. So it is also called running time. So it is called burst time. Second is arrival time. When a process enters in a ready state, it's called arrival time, which means when the process first came at a CPU, so it is called the arrival time. What is completion time? At what time the total execution has been completed of the process. Completion time, at what time the total execution has been completed of the process, which means at what time did the process has been completed. Fourth one is throughput. Number of processes in per unit time by CPU, means the number of processes which can be executed in per unit time by CPU is known as throughput. Fifth one is waiting time. For how much time the process has to wait in the queue. Suppose there are two processes P1 and P2. P1 requires 10 seconds and P2 requires 5 seconds. P1 came first, so CPU will deal with P1, and for 10 seconds it will keep on executing P1, and till that time P2 will be on hold. So how much time the P2 is on hold, it's called the waiting time. Now there are three, I have already told you there are three CPU scheduling algorithms, which are FCFS, SJF and round robin algorithm. So I'm going to teach you all of these three algorithms one by one. So there will be three videos of this playlist. The first one will be FCFS, then SJF, then is round robin algorithm. So today I am going to teach you about the second most easiest algorithm of CPU scheduling, which is SJF. The full form stands for shortest job first. Let's jump back to the numerical. As you can see, this is the numerical of SJF. SJF here stands for shortest job first, which means the process which has the lowest burst time will be executed first. Note has to be written that low burst time will execute first, which means the process which has the lowest burst time will be executed first. Now see, in SJF the criteria which is followed is burst time, which means the process will be following the positions of the burst time, and the mode here is non-preemption, which means there will be no interruption while the process is being executed. Now I've already told you about the formulas which is being used in all the numericals of CPU scheduling algorithm, which is first RT. RT stands for response time, which is CPU first minus AT, which is arrival time. CPU first means the process which is first interacted with CPU at which time, it's called CPU first minus arrival time. And what is TAT? Here it is total arrival time, which means completion time minus arrival time. And WT here stands for waiting time, which is equal to total arrival time minus burst time. So I have to clear the previous question which I have solved in FCFS. I am doing the same question with the SJF method. So here I begin. Now look, there are 5 processes: P1, P2, P3, P4 and P5, and the arrival time is already given to us, 25104, and burst time is 63834. And to solve this particular problem through SJF method, we need to make Gantt chart. Gantt chart here includes two things which are ready queue and executing queue. In SJF, note that the criteria followed is burst time, and note that low burst time will execute first. Now see how the question begins. Now first of all, make a ready queue table and executing queue table. Now in a ready queue, right, at 0 interval of time, 0 arrival time, is there any process which has arrived at 0? Yes, it's P4. But you might have a doubt, but I've said already you have to check the burst time, but no, because in starting of the question, at 0 interval there must be arrival time, because at 0 there must be a process which has arrived at 0. So we need to check first upon the arrival time. Is there any process which has arrived at 0? Yes, it's P4. Now P4 has arrived at 0 interval of time. Now similarly in the executing queue, right here P4. Note that ready queue and executing queue both work simultaneously. Now look, P4, it's being executed. Now how much time is required for P4 to be executed? It's 0 plus 3, it's 3. So with this we can say that our P4 is done. Now here's the main logic of SJF comes in picture. Now see, in executing queue 0 to 3, now see, is there any process which has arrived within this period from 0 to 3? Yes, it's P1 and P3. See, 2 and 1. So within this period of 0 to 3, we can see here P1 and P3 has arrived. But in SJF, you need to look through burst time, which process will be come first. So see, you can see here P1 and P3 has arrived because it's coming within the range of 0 to 3. Now which process will be executed first? You need to check the burst time. So this is what happens in SJF. You can see P1 has a burst time of 6 and P3 has a burst time of 8. So which process will be executed first? It's P1, because low burst time will be executed first. So right here P1, similarly right here P1, and how much time does P1 required here? So it will be P1, it's 6, so 3 plus 6 is equal to 9. Now see, you might have a doubt, why I have not written here P1 then P3? Because first P1 will be executed and you have to check upon the executing queue. Now you can see here the executing queue has reached up to 9. Now is there any process which has arrived within this time limit from 0 to 9? Yes, there are all processes which has arrived from 0 to 9. Now we have completed P1, so P1 is done. Now we are left with P2, P3 and P5. Now 0 to 9, is there any process which has arrived within this limit 0 to 9? Yes, all have arrived within this period. Now which process will come after P1? It will depend upon the burst time. So for P1, after P1, which process will come? We will see the burst time. So after P1, which has the lowest burst time? It's for P2 is 3, P3 is 8, and for P5 it's 4. So P2 has the lowest burst time. So right here P2 and P2 requires how many burst time? It's 3. So 9 plus 3 is equal to 12. Now our P2 is also done. Now you will tell if P3 will come or P5 will come, because P5 will come because P5 has lowest burst time. So right here P5. Now how much time does P5 required? It's 4. So 12 plus 4 is equal to 16. Now our P5 is also done. Now we are left with only P3. So right here P3, and how much time does P3 require? It's 8. 16 plus 8 is 24. So our P3 is also done. Now this is how we complete the Gantt chart, which is ready queue and executing queue. If you have a doubt, please rewind it and see where the main logic comes. It's upon the burst time. So which process will have the lowest burst time will be executed first. Now you might get a scenario in your exams or numerical that where you might be getting like same burst time. So you can see P2 and P4 here have the smallest burst time, or they're equal. So if they have equal burst time, you will check upon the second condition, which is the process ID. The process ID here means the process which has the lowest ID will be executed first if both the process have the equal burst time. Are you understanding what I am trying to say? If the burst time are equal, given suppose in numerical, you will check upon the second condition, which is look upon the process ID. The process ID which is having the lowest number will be executed first. Suppose P2 is 3 here and P4 it's also 3. So which will be executed first? It will be P2 because of the process ID, because P2 is less than P4. So I hope you get my point, what I am trying to say. Now we will complete this following tables very easy. So completion time for P1. Now see upon the, you are always have to if you're trying to complete this completion time, total arrival time, waiting time and response time, you always have to look upon the executing queue table, not the ready queue table. You always have to look through executing queue table. Now CT here means completion time. Now check for P1, how at what time P1 is completed. It's because P1 has completed at 9. So right here 9. And you might have a doubt, why not 3 here? Because at 3 the P1 is being executed to CPU. At 3 P1 is getting executed to 3 and it's got completed at 9, because 3 plus 6 is equal to 9. That's why. And for P2 it's 12, and for P3 it's 24, and for P4 it's 3, and for P5 it's 16. Now we need to calculate total arrival time. The formula of total arrival time is completion time minus arrival time. So 9 minus 2 is 7, 12 minus 5 is equal to 7, 24 minus 1 is equal to 23, 3 minus 0 is equal to 3, 16 minus 4 is equal to 12. Now we will do the waiting time. The formula of waiting time is total arrival time minus burst time. So 7 minus 6 is equal to 1, 7 minus 3 is equal to 4, 23 minus 8 is equal to 15, 3 minus 3 is equal to 0, and 12 minus 4 is equal to 8. Now check upon the response time. Response time formula is CPU first minus arrival time. So for check for P1. So P1 got its first interaction with CPU at 3. So 3 minus 2 is equal to 1. For P2 it's 9. 9 minus 5 is equal to 4. And for P3 it's 16. So 16 minus 1 is equal to 15. And for P4 it's 0. So 0 minus 0 is equal to 0. And for P5 it's 12. So 12 minus 4 is equal to 8. So our response time table, waiting time column, response time column, it's completed. Now we need to check upon the average waiting time, which will be asked in your numerical, the most important. So calculate the average waiting time. So here waiting sum of average waiting time, it will be 1 plus 4 5, 15 plus 5 20, 20 28. So 28 divided by 5, because number of processes, so the answer would come out to be 5.6. So the average waiting time is 5.6. I hope you getting my point, the average waiting time. I hope you got the concept of SJF. Now you can see in the previous video of FCF, we got that FCF average waiting time was 8, and here SJF it's 5.6. So by this we can conclude that SJF completes the process much faster, and the waiting time in SJF is very less respective to the FCFs. Now in my upcoming video of round robin algorithm, we will see if it's overcome SJF or not. So I hope you like my today's video of SJF, which is shortest job first. So in my next video I'm going to teach you about the round robin algorithm. So please subscribe to my channel, like and do comment on my video. So meet you next time. Thank you.